Hi everyone, today I have found all these remote controls, and as you can see there's like two Virgin Media and there's an Elba, so some Elba equipment which I probably no longer have, and I've got three here that I've got no idea what they belong to. So do these work? And if they do work, are they of any use at all? Also, if they do work, are they of any use? So, interestingly, the remote controls that I have for my TV and etc., it would be nice if I could test them, because sometimes you get a button that doesn't work, and unless you go through all the functions on the TV, you've no idea if all the buttons are working. So why not build a little device to test the remotes? So here's a little circuit I've come up with. As you can see, I've got a infrared diode, I've got a normal NPN transistor to amplify the signal, and I've got a emitter follower to drive the LED. Let's put this together. Some of the values obviously may need to change, as this is just a rough sketch. So let's put this onto a breadboard. As it happens, I have already put this onto a breadboard. Zoom out slightly. And let's connect this. And I will get a remote control. This is my TV control. So let's press, and as you can see, when I press the any button, the LED is flashing. So I can go through all the buttons, 1, 2, 3, 4, 5, 6. So there you go. It's an interesting little circuit. It could be useful to test your remote like every week, just to make sure all the buttons are working, because I did have an instant where one of the buttons did stop working, and I had to take the remote apart and clean all the buttons. But it would be nice if you could once a week just go through all the buttons and make sure they all are working. Let me zoom back out there and move that out of the way. I have a little box here which I can build this into. I have a little switch. I have a LED mount for the LED. And a box. Only a small box, but that will fit it, fit the battery and the switch and the LEDs. So the next thing to do is to lay out a circuit. Here's a piece of copper board, so I need to lay out the circuit on this and etch it and then put the components on. I will start to do that. I will use another piece of paper, and I will then lay out a circuit. Should be quite simple. Okay, I've got a piece of circuit board, and I've drawn it on the piece of paper. Now to draw the layout. So I think that's it. So the thing to do now is to cut this out, and we put this on top of the circuit board with a bit of sellotape. Just like that. So that's held onto the circuit board. Now I need to mark through the board with a centre punch, mark where the holes have to be. So one there, one there, one there, one there, and there. And we do this for all the holes. Okay, I have finished marking all the holes on that. Now I'll take the paper off, and there's the board all marked. Now all that needs to be done is to transfer the tracks onto the board. I use a piece of double-sided tape to stick that to the board to stop it moving while I draw the circuit. I have the etch resist pen. Now this is from RS Components. It is the only true etch resist pen. You can get etch resist pens that are advertised on eBay, but they are not true etch resist. They are just normal marker pens, so be warned. So now it's time to draw, to transfer the layout onto there. Okay, that is now drawn on, and what I could do to save etching fluid, this is the earth, so I can bring this round like that and fill that in, and fill that space in. Also, I could fill that space in. So there we go. So the next job is to etch that. So the video will continue after the etching process. This is called my Rock On, and this is my etching dish, and I'll put the circuit in there. I will get my etching fluid, pour that, not much, you don't need much, in there, and as you can see, I've started the table. It rocks backwards and forwards until the etching is done. So I will catch up when the process is finished. Okay, as you can see, etching is complete. So I need to clean off the etching. And for that, just a bit of alcohol. As you can see, it cleans up very nicely. Now that that's clean, I will need to clean that, and it has to be cleaned thoroughly, and then I shall tin it. So to clean this thoroughly, I shall need, I think, this little brush. It's a fine wire brush, and you only need to just go over it like this, and that should be more than enough to tin it. So that looks reasonably good. So I don't want to touch the surface of it. Now it's clean. So I'll bring back my tray. I don't need movement this time. And I shall pour in the tinning solution. You don't need much of this. I'll put this and prop the tray up. And pour in the tinning solution. Just to cover it, and we have to leave that now for probably 10 minutes. The etching took about 15 minutes, so this will take about 10 minutes. So we'll get back when that is complete. Okay, you can see the tinning process is complete. Took about 10-15 minutes, and so now it's time for drilling. So you can see now why I centre punched it before I etched it. So I won't bore you with the drilling, and I shall be back when it's done. Okay, circuit board is drilled, so it's now a question of putting the components on. So first component to go on will be the diode, which goes in. As you can see, diode is now in. I do have a link to go in, but I won't bore you with putting all the components on. That won't take a few minutes, and we'll be back when it's time to test it. As you can see, I have now mounted all the components on the board. Turn the board over, soldering's done, and I have connected a switch and the LED and the battery connections. So I've turned that on, and as you can see, I think it works from about, I don't know, half a metre away, which is quite adequate. So turn that off, and I can mount this in the case. I've already drilled the hole for the I've already drilled the hole for the receiver. That should just go in. That just sits in there like that, and the battery that comes over this way. The battery will just sit in there like so. And the lid goes on. So I turn that on, a remote, and there we have it. All I need to do is to screw the case on, and that's another little project complete. However, I did one slight modification, which I have shown on the circuit, and that is a 1 microfarad capacitor from the collector of the first transistor to the base of the other one, to the base of the emitter follower. The reason was it was DC coupled and the sensor was picking up the sunlight. If you pointed it at the sunlight, the LED would come on because it was directly coupled. So that was a very slight modification, which actually was quite easy because it went in place of the link that I'd put in. So it worked out quite well. Anyway, that's it. Turn it on, remote. So I hope you've found this one useful. Just a silly little project, but it may prove to be interesting for someone. Please subscribe to my channel and please hit the like button. That helps the channel and encourages me to make more videos. Maybe as simple as this, but they are probably useful for somebody. Bye for now.